Okay, great. Recording is started. So, good morning, everybody. Welcome back to Math 115. Let's see. So, today we're going to talk about a few things, but I do want to start with some reminders really quickly. Let me share the iPad screen. There we go. Okay, so really quickly, just a couple of reminders for you all. Exit slips from week 1 are due Friday at 11:59. Homework 1 on My Math Lab due on the same day at the same time, Friday at 11:59 p.m. So the exit slips from last week I extended just because some students were joining the class late, etc. So the exit slips from the 4 lectures of week 1 will be due this Friday. Thereafter, the exit slips will just be due 1 week from the day of the lecture at 11:59 p.m. So those ones got extended. Homework 1 is due Friday at 11:59 p.m. Oh, I have office hours today. From 9:30 to 11:30. So if you're confused about anything, just stay after class and we'll hold office hours for 2 hours. Let's see, is Jamie here today? Let me see here. Okay, it doesn't look like Jamie's in here yet. So the supplemental instructor has new hours. Be on the lookout for an announcement via email. We'll send you an email with those hours. I think they're like Tuesday, Thursday, and Sunday or something like that. And you can get extra help. It's like another office hour. And that's held by the SI, who's a student who did well in the class last semester, or previously, I guess. Okay, so that's all the announcements. So let's recap. What did we talk about last time? Last time we talked about all about square roots and nth roots, and we talked about how to simplify them, how to multiply them, how to rationalize the denominator, how to use conjugates. We had really a lot of material in there, including also how to deal with rational exponents, how to add and subtract radicals, and all of that good stuff. Okay, so that was kind of a big unit. So if you're confused by any of that, just stay after class and we'll talk over more of that stuff during office hours. I also have some factoring practice that if students are struggling with factoring, we can do some practice during office hours. So today what we're going to talk about is equations. Okay, it's going to be all about equations. We're going to talk about linear equations, and we're going to talk about quadratic equations. Okay, we're going to talk about both, and we'll solve some. And we're going to talk about rational equations, and we'll see a couple extra examples of more complicated things like equations with radicals or equations that are, quote, quadratic in form. Okay, so that's where we're going for the day. But before we talk about all these different types of equations, we should talk about what an equation actually is. So let me ask the class, can anybody tell me what the difference is between an equation and what we call an expression? What is the difference between an expression and an equation? Yeah, very good. Okay, great. Everybody already knows this apparently. Sweet. Okay. An equation has an equal sign. Very good. Okay. So you can just read that straight from the first part of the word, the equa. Kind of looks like an equals, right? It's the first four letters of an equal sign. So expression contains sums and products, etc., of variables and values. For example, 5x squared minus 23. There's an expression. We can even have rational expressions. We could divide it by something like 1 minus x. Okay, so that's an example of an expression. And an equation is just going to be two expressions connected by an equal sign. Apologize, my handwriting is really bad. I'm going to try to improve that. An equation is going to be two expressions connected by an equal sign. Okay, so if we have an equation here, which let's have an example. It could be something like 2x minus 3 equals 74. There's an equation. I can't see the notes. That's not good. Okay. Let's have a show of hands. Who can see my notes? Actually, who can not see my notes? Let's have a raise your hand if you can't see my notes. Okay, just Justin then. So Justin, you might want to try reconnecting to the Teams. Sometimes you got to close the entire app and reopen it. Otherwise, you might have to watch the recording if we can't get that working, okay? Oh, I think you should be able to just rejoin the call. Okay. Well, in the meantime, where were we? We were talking about equations here, so we want to talk about what is the domain, okay? The domain is something which we refer to, it refers to the variable which is in the equation, okay? And the domain is going to be the set of values for which both sides are defined. Okay, so the big ones are, notably, we cannot divide by 0 or take even-powered roots of negative numbers. Okay, so for an example, we might have the expression square root of x is equal to 7 over x minus 3. Okay, so here's an equation. So we've got square root of x equals 7 over x minus 3. And on the left-hand side, I have a even-powered root. It's a square root, which means the power of the root is 2. Okay, so we cannot take the square root of a negative number. I mean, we really can if we talk about complex numbers, but We're not talking about complex numbers right now. So we're not going to take square roots of negative numbers, and we are not going to divide by 0. Okay, so these are the two pieces of the equation which are going to give us trouble with respect to the domain. Okay, so as long as x is any positive number, the left-hand side is going to be okay. All right, as long as they take any positive number, the left-hand side is going to be okay. And the right-hand side is going to be okay as long as we don't make the denominator 0. So the number which is going to make that denominator 0 would be if we were to plug in 3 into this equation. Okay, so we want our domain will be the set of positive numbers, but not 3. So we could write that down in a few ways. We could write it, first we could write it like 0, comma 3 with a parentheses, union 3, comma infinity. We could write it like that. Or we could say something like x greater than or equal to 0, x not equal to 3. Let's see, is there any other way we could express it? Yeah, not really. I think those are the main ways that we would express the domain of this equation here. Okay, so it's the set of values which we can plug into the variable, and both sides of the equation make sense. Okay, that is what the domain is. All right. So remember, when we're talking about the domain, or the solution set for that matter, we're talking about a set. Okay, so a set is going to be a collection of numbers. So I wrote some examples down on the right-hand side here. For example, this first set is the set of numbers 1, 2, and 3. If our domain was this, then 1, 2, and 3 would be the only numbers which we could plug in, which would make those two sides work. Okay, or we might have something like 0, comma 1. In this case, the left-hand endpoint is included and the right-hand endpoint is excluded because we have a bracket on the left and a parentheses on the right. Okay, and this funny symbol here is what we have for the real numbers. Okay, you could write this symbol, or you could write something like you could write something else. You could write all real numbers, all real numbers. Oof, that's an M. Numbers. These two mean the same thing. Infinity, negative infinity, comma infinity. Talking about all real numbers again. Okay, so those are some examples of sets. So let's talk about solution sets. Okay. How did I want to express this? The solution set for an equation is the set of values which make the equation true when plugged in for the variable. For example, we might have y squared equals to 9. Then our solution set, sometimes I'll abbreviate it solution like SOLN. Our solution set is going to be a set of numbers And it's the numbers that make this equation true. What are they? What numbers can I plug in for y to make this equation true? Yep, Catherine's got it. It's going to be 3 and -3. Okay, student, let's see here. Somebody wants, Kumar wants to see domain explained again. I can absolutely explain the domain again. Okay, so when we have an equation, so let's bring our attention to this right here. Okay, this equation. When we talk about the domain of a variable, okay, what we're talking about is what are the acceptable values which we could plug in potentially for x, okay? We're not necessarily talking about values which are going to make the equation true per se. We're just talking about, we're kind of looking individually at each of these two sides of the equation, okay? We're looking at each of the two sides. And we want to say, before we really move forward, let's have a statement about when this equation even makes sense, let alone is true, okay? And so if I were to say, try to plug 3 into this equation, what I would get is square root of 3, fine so far, equals to 7 divided by 0. Forget about the fact that these are not going to be equal. The right-hand side does not even make sense, okay? So the domain is going to be the set of values for which both sides of the equal sign make sense, okay? And we can't divide by 0, so we have to exclude the number 3, which if we plug in for x, we would get 7 divided by 3 minus 3, and that would be 0, okay? So the domain is just going to be the set of values which we can plug into x and get something which is defined on both sides. Okay? Have I explained that in enough detail? Got it. Okay, fantastic. Okay, so this is an example of the solution set for this equation. We have y squared equals 9, and there's two numbers which we can plug in, which are going to make it true. So the solution set is the set which contains both of those numbers. So you can think of these brackets here as being kind of like our bucket, and inside of our bucket we put all of the numbers which are going to make this equation true. So 3 is one of those numbers, so we throw it in the bucket, and -3 is another one of those numbers, so we throw it in the bucket. We use these curly braces, which I'm terrible at drawing, as you can see, but they're supposed to look something like this. Oh, Jesus, I cannot do this on the iPad. There we go. They're supposed to look like that. And these are typically what we write down when we're talking about a set, which is going to be like a enumerated list. So like 1, 2, 3, 4. We're talking about the numbers 1, 2, 3, and 4, but not the ones that are in between. Okay, so the only numbers that are in this set are the ones which we specifically list. We use the brackets and the parentheses when we're talking about a range of values. Okay, so that's the solution set. So before we move on, are there any questions about what equations are and what we consider to be the domain and the solution sets of an equation? Okay, seems not, so we'll move on. All right, so let's talk about linear equations. I'm going to start speeding up just a tad bit because we have a little bit of material to get through. I want to make sure we have time for all of it. So let's talk about what a linear equation is. A linear equation is an equation that has this following standard form. We write it as AX is equal to B, or AX minus B is equal to 0, or something like that. Let's see, I better make sure I put it in the right. They say AX plus B is equal to 0. Let me write it in the way that the book likes it. All right, AX plus B is equal to 0. Where A and B are real numbers and A is not equal to 0. Okay, so this is what we call a linear equation. Okay, why do we call it linear? Well, we call it linear because the power on x, the highest power on x is 1. Okay, when the highest power of x is 2, we'll call it quadratic. When the highest power of x is 3, we'll call it cubic, and so on and so forth. Okay, and the reason we call it linear is because if we were to graph the equation y equals ax plus b, it would be a graph of a line with slope a and y-intercept b. Here's y equals ax plus b. Okay, but that's just to help you remember why we call it a linear equation. And the way we solve it is just by taking, okay, well, we take ax equals to negative b, and then we divide both sides by a, and we'd get x is equal to negative b over a. Okay, so that's how we would solve a linear equation. Okay. All right. This is our solution set, just x equals to negative b over a. Okay. So let's have a practice of how we solve these guys. Basically, we're just going to use PEMDAS here, and we're going to try to isolate x. Okay, so here we've got x all over the place and tied up in a bunch of parentheses. So PEMDAS dictates we should start from the inside out. What we should start with is the innermost set of parentheses here. Okay, and what we should do is we should distribute this 2 over there. So let's first do that. We take 6x minus parentheses, bracket that is, 3x minus 2x. And remember, this negative 2 comes onto this x becomes minus 2x. The negative 2 comes onto the negative 2 should become a plus 4 equals 11. And now what we want to do is distribute this minus sign onto each of our terms. And what do we get? We get 6x minus 3x plus 2x, since minus a negative is a plus, and then minus 4. And that's all equal to 11. And now we can kind of combine like terms on the left-hand side. We would then have 6x minus 3x plus 2x, that's going to be 5x, minus 4 equals 11. And then we would add 4 to the other side. We'd have 5x is equal to 15. And then we would divide both sides by 5, and we would have x equals to 3. Okay, so that's how we would solve this linear equation. Okay, it's about isolating that variable. Okay, so in particular, we want to get all of the x's together. Okay, in our original equation, we've got 6x here, negative 3x, we got an x inside. We want to get them all together, and once we have them all together, they all came out to 5x. And then after we have all of our x's together, we just move all of the numbers to one side and all of the x's to one side. And then we divide by the coefficient here, 5, on both sides to get rid of that. Okay? So hopefully this is familiar to everyone. But if it's not, then come to office hours today and we'll talk more about it. Okay, so that's a linear equation. So we can step up the difficulty a little bit with the quadratic equation. Quadratic equations are equations that have the form ax squared plus bx plus c equals 0, where a, b, c are real numbers and a is not equal to 0. Okay, because if a was equal to 0, then this whole term would go away and we'd be left with just bx plus c equals 0, and that would be a linear equation. Okay, so a shouldn't be 0. Okay, so for example, we could have something like, I don't know, 4x squared minus 27x plus 3 equals 0. Okay? And remember, this left-hand side is what we might call a, quote, quadratic expression. And the entire thing, equal sign and 0 included, we might call a quadratic equation. Okay? That's the difference there again between expression and equation. Okay, and we have two main ways of solving them. Okay, we have factoring and we've got the quadratic formula. So let me show you guys first how we would factor this, or how we would solve a quadratic equation by factoring. So here's the steps for factoring. The first thing, get everything on one side. It's going to be the first step every time. So let's do that first step. We would get 2x squared plus 5x minus 3 equals 0. Minus 3 equals 0. Okay. And from here, we just want to factor. Okay, so let's have some practice factoring this. You can do it one of two ways. I could use grouping, or I could kind of just try to ham-fist my way through it. I know since I've got a 2x here, 2x squared here, the only factors for 2 are 2 and 1. So one of these has got to be a 2x and the other one's got to be a 1x. I can also read what the signs should be. I've got a plus in the middle and a minus on the end. Okay, which means that I should have one plus sign and one minus sign. Yet to be determined where they should go. And I've got 3 here. Okay, which factors as 3 and 1. And I've got 2 here, which factors as 2 and 1. If you want to do this without grouping, what you want to do is look at these two expressions, 3 and 1 and 2 and 1, and think about how you can multiply either 2 times 3 and 1 times 1, or 2 times 1 and 3 times 1 in order to get plus 5. Okay, so let's see here. I think we can do it with 6 minus 1 would be 5. So we want a plus 3 here to get our 6x, and then a minus 1 here to get our minus 1x. And if we were to FOIL this out again, we'd see we would get that expression. Okay, so I just wanted to see you guys to see the kind of more streamlined process for doing this factoring. But you can always rely on grouping. Okay, you can always rely on grouping. Okay, so we've factored this. And if you want practice factoring and you want to see more about how I just did that, stay after class for office hours and we'll talk more about factoring. So now we've factored, and I should keep my equals 0 here. And now the third step is set each linear factor equal to 0. Now, why do we do that? What this thing looks like is, okay, a times b equals 0. I have two numbers being multiplied together, and I get 0. The only way that that can be true is if either a is 0 or b is 0. If a and b are numbers like 2 and 3, we're never going to get 0. One of them has to be 0, so it's either 2 times 0 or it's going to be 0 times 3, or it could be 0 times 0. So we require at least one of these two factors to be equal to 0. So we just set them equal to 0. So we'd set 2x minus 1 equal to 0. Then we would get x equals 1/2. And then we set x plus 3 equal to 0. And that would tell us that x equals -3. So the solution set for this equation, oh, I even wrote it down there already. The solution set is going to be (1/2, -3). I don't know why these curly brackets are so hard to draw on like the slippery iPad screen. Well, you guys are just gonna have to deal with my awful brackets. Okay. So that's gonna be our solution set. Are there any questions about how we solved that quadratic equation using factoring? Okay, seems like no questions, so we'll move on. Let's try doing it with the quadratic formula. So why don't we talk about, why don't I add a page here? I'm going to add a page and I'm going to move this down a little bit so I can talk about what the quadratic formula actually is. I'm just going to give it to you. The quadratic formula says that x is equal to -b plus or minus the square root of b squared minus 4ac all divided by 2a. Okay, I really recommend that you memorize this, by the way. You won't have to, since your exams will be open book and open note, but it's a useful thing to memorize. Plus, there's a song for it, too. I don't remember how it goes, but there is a song, so you can learn that if you have trouble remembering it. Okay, so this is the formula where our quadratic equation is ax squared plus bx plus c equals to 0. Okay, so we just take the coefficients a, b, and c, and we plug them into this formula, and that'll give us exactly what our solution set is going to be. Okay, and it's going to give us two answers. It's going to give us the first answer will be negative b plus the square root of b squared minus 4ac all over 2a, and the second answer will be negative b minus the square root of b squared minus 4ac all over 2a. Okay, so that's the quadratic formula. So let's try using the quadratic formula to solve this equation. Again, the steps are going to be get everything on one side and identify the numbers a, b, and c. The second step will be to plug in to the quadratic formula. And the last step will be simplify. Okay, so let's do it. Our first step, we should get everything on one side. Oh, question here from Jake. Will we ever use this to solve quadratics or cubics? Okay, so we are not. You mean factoring or the quadratic formula? So you asked that 3 minutes ago. We were probably still talking about factoring. We might use factoring to solve a cubic at some point if we learn. I can't remember if we learn long division in this class or not. We might. But we won't use the quadratic formula to solve anything other than a quadratic equation. There is a cubic formula that's much, much, much uglier and longer, and you could never hope to memorize it. There's even a formula for the degree 4 polynomial. And it's a really famous result in algebra that there's no such equation for a degree 5 or a quintic polynomial. That was proven by Galois. Okay, but that's a tangent. I think I hopefully have answered your question. We're not really going to use the quadratic formula for anything but quadratic equations. We might use factoring to solve a cubic, potentially a quartic or something like that. Okay, so let's see. Let's get everything on one side here. We've got 3x squared, move the 5x over, move the 2 over. That's equal to 0. And these are going to be our a, b, and our c. Okay, so a is equal to 3, b is equal to -5, and c is equal to -2. So we get x is equal to, we should have negative b, that's +5. And we should have plus or minus the square root of b squared is 25 minus 4 times 3 times -2. So that's going to be negative 4 times 3 is 12 times 2 is 24. So that's just 4ac there. So we make those negatives the plus plus, and we're going to divide by 6. So x is going to be equal to 5/6 plus or minus the square root of 49 over 6, which is going to be x is equal to 5/6 plus or minus 7 over 6. So our two answers will be x equals 12/6 or 2, or x equals, let's see if we were to subtract 7 instead, -2/6 or -1/3. All right, so that's how we'd fully simplify that. Okay, any questions about applying the quadratic formula? Okay, if there's no questions, then we will move on. Okay, well, I better hurry up. I really want you guys to see this final example. Maybe I'll save it for next time. Okay, well, let's move on now, and we'll talk about solving this rational equation. Okay, so these are just going to be a couple examples. These are really just to refresh your memory from what is hopefully review. If it's not review, or if you're rusty on this stuff, please come to office hours. So I'm going to solve these ones a little bit quicker. So here we have a rational equation. We've got 1 over 6 plus 1 over x plus 1 is equal to 1 over x. Okay, this looks a little bit intimidating, but all we want to do is just kind of multiply both sides of this equation by the least common denominator, okay? If we multiply everything by 6 first, then we would have something like this one would become a 1, and then the other ones would just be 6 over those things. So we would have kind of effectively removed the denominator of one of our things here. So what we're going to do is we're just going to multiply the entire thing. So I'm going to multiply both sides times the least common denominator, which is going to be 6 times x plus 1. And what we get is 6x plus 1 divided by 6 plus 6x times x plus 1 divided by x plus 1 equals 6x times x plus 1 divided by x. And in each of these, we can cancel some things. So what do we get? X times x plus 1 plus 6x equals 6 times x plus 1. Let's expand it out. We get x squared plus 6x equals 6x plus 6. This looks like it's going to be quadratic. We should move everything to one side. So we'll subtract 6x from both sides. We'll get x squared plus x. And then I'll subtract that 6 over to the other side as well. Minus 6 equals 0. This is quadratic. So we factor. This one factors as x plus 3 and x minus 2. Remember, we want two numbers which are going to multiply to -6 and add to +1. Those two numbers are +3 and -2. So this is still equal to 0. So we then just set each one equal to 0 and solve. So we're going to get x equals either -3, that would make the left-hand factor 0, or x equals +2. Because if we plugged in +2 right here, then the right factor would be equal to 0, making the equation true. So that's how we can solve a rational equation. It's basically about just multiplying by the LCD and turning all of your fractions into not fractions anymore. Any questions about this one? Okay, no questions. Here's how we would solve an equation with a radical. Right now, the x, which we want to solve for, is underneath a cube root. So we're going to eventually want to undo that cube root. And the way we undo a cube root is the same way we undo a square root. If we want to do undo a square root, we square it. If we want to undo a cube root, we should cube it. But what we should do first, before we cube it, is probably move this 4 over to the other side. I'm going to do that first. We'll have cube root of 2x plus 1 equals -1. And now we're just going to cube both sides. So we're going to make the left-hand side 2x plus 1. That's what we get if we cube a cube root. And on the right-hand side, we'll have -1 times -1 times -1. We have an odd number of negative signs, so it's going to be a -1. So then we're going to move the 1 over here. We'll get 2x equals -2. And then we'll divide both sides by 2 and get x equals -1. Okay, 2x -2, x equals -1. Okay, so that's how we'd solve this equation with a radical. Basically, it's just about undoing the nth root by taking a power of n once you have the root isolated. You could cube both sides right from this. No, you couldn't cube both sides right from the start because you'd get, yeah, so you have to isolate. Remember, isolate cube root, then cube both sides. That was our strategy for this one. Okay, so really quickly before we're out of time, I want to talk about this last example, which is things which are, quote, quadratic in form. Okay, so what I'm referring to here is equations which almost look like a quadratic, but for this kind of over 3 here, right? If we were to get rid of this over 3 on each of these powers here, we'd have x squared minus 7x plus 6 equals 0, and that would be quadratic, okay? So the game we play here, okay, the game we play here is to try to do what we call a change of variables. So we get a new variable u, okay, we get a new variable u, which is going to make this equation into a times u squared plus b times u plus c. So in our case, we should pick u to be equal to x to the 1/3. Then we rewrite this equation as x to the 1/3 squared minus 7 x to the 1/3 plus 6 equals 0. And we rewrite this as u squared minus 7u plus 6 equals to 0. And now to solve this equation and get the x values, what we're going to do first is we're going to use factoring to solve this u equation, and then we're going to back substitute using this u equals x to the 1/3 equation. Okay. So let's solve it using factoring. We'd factor as u minus 6 times u minus 1. And that's equal to 0. So u should be equal to 6, or u is equal to 1. So we're nearly there, but they asked us to find the values x, which make the equation x to the net 2/3 power minus x to the 1/3 power plus A.6 is equal to 0. That's what they asked us for. We've given u values, which make this other related equation equal to 0. So we just have to take one more step here, which is to use this critical piece of information, u equals x to the 1/3, to back substitute our u values into x values. And we do that by taking u equals x to the 1/3 and taking both sides to the third power. So u cubed will be equal to x. And I know that u is equal to 6 or 1, which means that x will be equal to 6 cubed, or x will be equal to 1 cubed, or 216 and 1. Okay. So that's how we handle equations which are, quote, quadratic in form. Another really common one is you'll see something like x to the fourth minus 2x squared plus 1. You'll see something like this, where this is again quadratic in form, where you'll just let u equals to x squared. Okay, because you can see that this x to the fourth is nothing but x squared squared. Okay. I think that's all for today. If you have any questions about any of what we just did about quadratic in form, or about any of the rest of the lecture, or about anything else, please stay after. I have office hours right now until 11:30. So if you have another class, you can leave and come back if you want. But that's all for today. Thanks for listening, and have a good one. So Michaela, Marissa, Tommy, any of you guys have questions about what we talked about today? Or about something we talked about before? Jake is back as well. Maybe he has some questions.